Hey everyone, my name is Stani. I'm the founder and CEO of Aave, and Aave is a DeFi project that is practically a decentralized money market for lending and borrowing. And yeah, today I want to share some secrets in terms of when it comes to building decentralized financial applications on Ethereum, and what kind of things you should take into consideration. And also we're going to talk a bit about composability in general, especially in DeFi, and also a bit about the security aspect and some other cool stuff. And in terms of like main kind of focus point here will be this function that we have at Aave, which is called credit delegation. So it's pretty new thing that we recently added into the protocol, and practically I will show kind of like some of the examples and cool things you could do with the credit delegation and how it could actually help whatever you're building. Yeah, some background information. There might be new people here that do not know what the Aave protocol is or how it works. So in essence, it's practically a set of smart contracts deployed on the Ethereum network. And these smart contracts are doing certain type of financial activity. And in Aave's case, it's pretty much practically a money market of various asset reserves. And those asset reserves can be stable coins or other kind of assets. And what's interesting here that as a protocol, we can practically deploy any kind of a money market, which includes different kinds of assets with their own risk parameters and interest rate formulas for yield. So in essence, the user flow is pretty simple. We have a user that comes into Aave and wants to earn yield on the asset that they have currently. It might be DAI, it might be USDC, or it might be Ether as well. In the similar way as you will in the future, you'll be able to deposit ETH into the 2.0 staking facility. People already get interest in DeFi by depositing their ETH into various lending protocols and so forth. And what's interesting about here is that all of the money markets consisting of various assets, and usually there is a certain amount of assets that are deposited and certain amount of assets that has been borrowed from the protocol. And from design perspective, what's interesting here is that these reserves are usually, there is more overheads than actually the consumption, which means that roughly 25% of the assets in our protocol is borrowed out. So currently there is a bit over $500 million worth of assets locked in the protocol, and roughly 1/4 is borrowed out. So it's kind of like designed in a way that those assets aren't consumed completely. But in terms of user experience, what it allows to have is that practically if you deposit an asset now, you can withdraw it, let's say on the next Ethereum block or at some later stage, because there is more assets in the pooled model. And this is pretty cool, especially if you're building something on top of Aave, where you just need to have certain type of yield for a short period of time, and you want to basically utilize those assets somewhere, some other place. So that's pretty interesting. And also, so practically everyone at Aave is a depositor, and some of the depositors are also consuming the liquidity, so they become borrowers. So they're earning on the asset they deposit, and on the other side, when they're borrowing something, they're paying interest. Sometimes they're earning more than they're actually paying interest, depending on which assets they're depositing and which they're borrowing out. And of course, we have this native flash loan functionality So if you have been on Ethereum following the DeFi space for a while, you probably know what are flash loans, and I will come back to them later and demonstrate the technicalities related to that. But in essence, as a protocol, we can create different kinds of money markets. And during this year, we created another money market where you can use your Uniswap liquidity shares as a collateral, which is pretty cool in terms of the composability perspective. So when you deposit to Uniswap to provide liquidity on a pair, what you can actually do is that you get so-called liquidity provider shares that represent what you deposited into Uniswap, and you can use them as a collateral in another Aave money market. And this kind of like showcases a bit the composability that we have in the Ethereum ecosystem. So if you're building something, you pretty much notice that any smart contract that is deployed into the mainnet, you can practically interact with it. So that's the interesting part. So decentralized finance is practically an ecosystem, but it also doesn't apply to DeFi specifically, but the whole network. So any kind of thing that is deployed on main Ethereum network, you can find composability and create new products and services. So probably first time ever something like this has been done on this scale as we have it today in Ethereum. Practically any developer, any part of the world can create a product that composes and consumes many of the protocols and creates value for the end users. And this is like one of the coolest value propositions of the blockchain, actually. Yeah, so pretty much there's quite a lot of value locked in the smart contract. So there's two important factors here. One factor is that it really showcases us how much the space itself has grown over a period of time, but also it showcases that when you're developing products, especially financial products, one thing you need to consider is that even if you deploy some kind of like a small functionality, but it stores a lot of value or controls a lot of value, it might, in Aave's case, it's a baseline protocol. So usually there's the assets are stored in the protocol, but it might be an aggregator that switches the deposits from one protocol to another. And what is important to notice is that even if you deploy something small and simple, it might become very used because of this permissionless access to whatever you build. And that is why like security is one of the most important things that you need to consider when you're shipping to the main Ethereum network. And also the chart is interesting because it also boils down to the ability to flash borrow liquidity from Aave, and I will explain later because you can actually use the whole value that is locked in the smart contracts. And as you see, this is a snapshot of one of the money markets that we have, and there's different kinds of currencies assets there that you can deposit. So you are earning on one side yields, and on the other side you can borrow any of the assets that are listed in the protocol, and practically you are paying one rate, and when you're depositing you're getting another rate. So if you think about it, like usually when you borrow an asset, you pay more compared to what you could earn on that same asset if you will deposit. And this boils down to the design system that we have, where the liquidity is pooled, mainly because of the reason that you can withdraw the liquidity at any time you want, unless there is some sort of a bank run. And this kind of like a design decisions is something that comes quite frequently to you when you're building systems, whether it's DeFi or not. For example, before Aave, we used to develop a lending protocol called ETHLend, short from Ethereum Lending. It was the first lending protocol in Ethereum. And what's interesting about ETHLend is that it was actually a peer-to-peer order matching lending marketplace with fixed time periods for the lending and borrowing. And in that case, what we noticed that we had this kind of like an order matching challenge to combine the liquidity and let the liquidity meet each other. And in this particular design, we actually have a bit more different model because the liquidity is pooled in the same way as the liquidity is pooled in Uniswap. And definitely as a design choice, this really brings sort of flexibility, but then it brings lower deposit yields for the depositors. And why it's important to understand like why these decisions are very difficult when it comes to designing protocols or products is that when you're dealing with smart contracts, usually you have this restriction of immutability. That's the value added that you get when you build things on smart contracts, unless you have a set up governance system that you can actually change some part of the code. So practically, you kind of need to design systems in a way to take into consideration that the economical model that you have supporting your product is the most efficient for the use case that you are applying. You could compare building smart contracts something like building hardware. After you ship your product, it's more challenging to update it, even if you have governance, because changes are always something that is requires effort to pull. One interesting thing we have at Aave is practically so-called A tokens. So A tokens are interest-bearing tokens. It's practically a deposit note that you get when you deposit into Aave. And what's interesting here is that when you deposit, let's say 100 DAI into Aave, you get in return 100 ADAI. And how we designed the A tokens is pretty interesting. So we didn't follow the very kind of strict application of the ERC20 standard, even though like our A tokens in the next version are ERC20 compliant. But the reason is that we created quite a unique way of crediting the interest that our users are earning into their wallets, and we did it algorithmically. So practically, whenever a balance of this token on a specific user account is called, it will update. So practically, if you have some A tokens in your MetaMask or Trust wallet or in MyEther wallet, as often the wallet provider calls this function practically to refresh the balance, your balance will algorithmically increase. And this is quite novel thing compared to the model where you need to claim or make a transaction to claim what's yours. And practically, why we did this kind of like a design decision is that it's more user-friendly in the sense that when you have a currency that automatically increases based on what you are saving, you practically have a permissionless savings account, which is pretty cool feature when, for example, you are in you or your user base is in a country where there's a lot of inflation, there's no access to let's say USD denominated savings account due to the lack of opportunities or with the current banking structure. And that is the kind of choice we made. And one of the things we had like challenging with A tokens is that it's difficult to add them, use them in a automated market maker protocols, like for example, Balancer or Uniswap, because of the constant increase in balance. And definitely this is something that we are improving in with the ERC20 standard that we're applying in the version 2 A tokens. But when we made this decision, actually we were more leaning towards user experience. So it's not always all about following something that there is, but also kind of like thinking on how you could improve the narrative that you're creating. And now, as of today, we've seen multiple kind of like iterations of the A tokens from other projects using the same solution. And this is like very interesting to see because it really saves gas in the sense that you don't need to claim those earnings. And you can actually even send those earnings to someone else. You could send AUSDC to someone else and it keeps on increasing in balance. And you can also redirect interest rate. So the amount of A tokens that usually users are holding now is growing quite substantially. So as a design decision, having tokenized form of a position is quite interesting in DeFi for a couple of reasons. The reason one is that it allows you to actually safely store that kind of position or that that functionality somewhere in your cold storage, for example. And this is a snapshot, for example, from Gnosis Safe of the amount of A tokens people are storing. Each and every asset has their own A token. And what's interesting about it is that when you are tokenizing things, you give the choice for the user to actually decide where and how they are storing their positions, or how they are actually interacting with it. They could actually send to another person if they want to give the position to someone else. And of course, like another important point boils down to the composability. So now that you have this A tokens, it's very practical and easy to build things on top of Aave or whatever you're building in DeFi. For example, you might be building some new kind of a product. It might be fixed interest rates. It might be something completely else. And practically, you can invite the A token holders to your system by allowing them to function that way. And I think we saw quite a lot of things related to this DeFi summer with all of this yield farming activity, where basically you had to use some sort of asset, and that is one way to invite a community or bring functionality. And in terms of credit delegation, which is today's kind of my main focus point that we're going now, I actually will show you how these A tokens are used in this credit delegation functionality. And so in short, credit delegation is pretty simple and straightforward. So one person comes to Aave, deposits into the protocol, and then instead of borrowing, they just delegate their credit to someone else. And that is practically under collateralized loan. There's two ways to do credit delegation. It can be smart contract based. So you delegate to a smart contract that can only do predefined functions and is immutable or has some sort of governance features. Or you could delegate it to someone else and secure that transaction with a agreement, as we did with OpenLaw and Diversify, which was the first credit delegation. But the very important part here is that what you're enabling is you're enabling other parties to actually borrow from DeFi, borrow from Aave actually, without having any kind of collateral requirement, because the delegator is the one who is using the collateral, but actually the entity that is drawing the credit is a third party. And it's pretty interesting, kind of like a proposition for the users, because and also hold the protocol, because 75% of the depositors, they are not actually borrowing, they're just depositing to earn additional yield, and that's pretty fine. But to increase that borrowing capacity and to increase the yields that depositors are getting, they could delegate their credit either one by one or some collective way into a vault, and earn more from that additional relationship. So one way to delegate credit is to delegate to someone you trust. So let's say you deposited into Aave, DAI, you're earning on DAI, and then let's say you want to, your friend needs a loan, and you want to delegate to your friend, and your friend pays you more interest. And besides that, you and your friend could make a legal agreement or some sort of written agreement in the sense that your friend will return their loan and so forth. So this is kind of like a use case where you could actually draw liquidity from DeFi into centralized finance even, or into traditional finance. I could see a use case in the future where there might be some sort of debt market for credit delegation, where people could delegate their credit to entities that practically have some sort of high standing or very high reputation. It could be, for example, financial institutions that are seeking credit from markets, because currently they have to take private placements or issue bonds to fund their, let's say, lending activities or whatever is their financial activity. And with credit delegation, you could actually source, let's say, stablecoin liquidity and then convert them to USD and fund people in the real life. So that's one thing. But one thing that I'm more interested about myself is the credit delegation to smart contracts. So you practically delegate credit to a smart contract that has predefined functions. So, for example, if you guys know this project called Wiren, so it's pretty new one. I'm not sure how familiar people are here with the DeFi space and whatnot. So I'm going very widely this example. So when you deposit link into Aave, you get Aave, and there's a vault in Wiren, which is YA link. So when you deposit your A link, which is the A token, there, practically that vault and its strategy is borrowing with credit delegation with 50% loan to value ratio from Aave, and then they're practically earning yield by farming different kinds of tokens in DeFi and generating more yield for the A-Link depositors. And because in terms of like smart contracts, it's closed loop system. So we can read the YA-Link vault, we can read the Aave protocol, we can read the strategy of the YA-Link and read whatever it is depositing the contract. So we kind of understand that actually there's no credit risk here, because the worst case scenario, those funds could be called back and returned into the Aave protocol. And this kind of like a closed loop smart contract system enables borrowing without actually having a collateral, but in a system where the default risk is limited. And I'm pretty sure that there could be like a lot of interesting use cases for this. And it's a feature that probably will be more utilized over a period of time. And technically, how the credit delegation works and has been built. So we have the Aave protocol, but we created this Aave collateral vault proxy contract with Andre from Wiren, and it's pretty much a Spark contract on top, built on top of the Aave protocol. So it's not directly natively in the current protocol, but it's built on top. And practically there is a function called deploy vault. So when you deploy a vault, you create a new credit delegation vault, which practically means that that new vault will be the strategy to borrow and also the delegation on what kind of address can borrow from Aave. And as a strategy and you know those parameters, you could basically set a maximum borrow and increase or decrease that borrow limit. And the delegators are technically using the A tokens that we previously were discussing. They come into your vault when they're interacting, and they're depositing any kind of A tokens that the protocol has, and then that increases the borrow capacity of the vault that you deployed. And then practically the borrower can draw the credit by calling this borrow function. And what happens in the background is that as the vault, it becomes one of the borrowers of the or actually it's first a depositor in the Aave protocol because of the A tokens, but secondly, it has the capability to borrow against from the protocol with the using the A tokens as a collateral there. And practically the borrower borrows, let's say USDC, and then you can do whatever you want to do in DeFi. I recently saw in the ETH Online hackathon a project where you could borrow with the credit delegation, and then you put a margin, and practically you have initial margin, and then you have actually a way to farm or do different kinds of financial transactions, supply liquidity, deposit in other lending protocols with initial margin. So there's a lot of interesting stuff you could do. And then you have the borrow repay functionality, where you can repay basically whatever you borrowed. And yeah, and then the delegator itself, once the loan is repaid, you can withdraw your A tokens, which basically means that you abandon the vault, and then you're back again in the Aave protocol. Yeah, so the documentation of the credit delegation can be found at docs.aave.com. Very fascinating. If you want to build other stuff on Aave, it's the same address. What I can tell you about our upcoming version 2 is that we're going to support the credit delegation natively in the Aave protocol, and it's built directly into the token where you actually have those allowances. And this is going to be pretty interesting feature in the version 2, but I also expect that a lot of things could be built by using this feature in the Ethereum ecosystem. Yeah, that was pretty much my presentation. If you have any kind of questions, here's a QR code to our Telegram group, and also aave.com/discord is our Discord server. If you have any questions, our technical team is always happy to assist, and especially if you have questions also related to, let's say, building in general on Ethereum or security-related questions, though feel free to come and ask. We've been building for a quite long time in the DeFi space, and also like in Ethereum in general, and we're always happy to help newcomers that are coming into the space and building something interesting. And also, I have to say that we're also hiring developers. If you haven't found a project that you like to build yourself, we're always looking for new recruits. And also, we have a grant program. So if you want to build something and you need a grant, feel free to reach us out. We're happy to share that information as well. And yeah, and that was pretty much it. And thank you, everyone.